Good day, this is the Professor, drwillphd, PhD. Today's Tuesday, July 26, 2022. It is 1:55 and 31 seconds, AM Eastern Standard Time. And today's research, photonic computing. So let's hop to it here. Ultra-fast photonic computing processor uses polarization. Date June 15, 2022. Source, University of Oxford. The new research uses multiple polarization channels to carry out parallel processing, enhancing computing density by several orders over conventional electronic chips. Researchers have developed a method using the polarization of light to maximize information storage density and computing performance using nanowires. Light has an exploitable property. Different wavelengths of light do not interact with each other, a characteristic used by fiber optics to carry parallel streams of data. The similarly different polarizations of light do not interact with each other either. Each polarization can be used as an independent information channel, enabling more information to be stored in multiple channels, hugely enhancing information density. We all know that the advantage of photonics over electronics is that light is faster and more functional over large bandwidths. The aim was to fully harness such advantages of photonics, combining with tunable material to realize faster and denser information processing. The research team developed a hybridized active dielectric nanowire using a hybrid glassine material, which shows switchable material properties upon the illumination of optical pulses, and each nanowire shows selective responses to a specific polarization direction, so information can be simultaneously processed using multiple polarizations in different directions. And by using this concept, researchers have developed the first photonic computing processor to utilize polarizations of light. And since the invention of the first integrated circuit in 1958, packing more transistors into a given size of an electronic chip has been the go-to means of maximizing computing density, the so-called Moore's Law. However, with artificial intelligence and machine learning requiring specialized hardware that is beginning to push the boundaries of establishing computing, the dominant question in this area of electronic engineering has been, how do we pack more functionalities into a single transistor? And this is just the beginning of what we would like to see in the future, which is the exploitation of all degrees of freedoms that light offers, including polarization, to dramatically parallelize information processing. Definitely early stage work, but super exciting ideas that combine electronics, nonlinear materials, and computing. Lots of exciting prospects to work on, which is always a great place to be in. Good day, this is the Professor of Applied Physics, Space Science, and Electronic Engineering. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.